Hello everyone, welcome back to my channel Xgene and Protein X. In this tutorial video, I want to talk about Western blot troubleshooting tips. So here I'll cover mostly the issues that we get in the Western blot. So here I will cover the all of this kind of issue how to solve. So you need to pick the right one that you need. So first is the gel electrophoresis issue. So this is the first step of the Western blot. So here in some cases we find that this process is very slow. So that is the tips is here that use freshly prepared running buffer using the DD water. So in some cases we use the distilled water to prepare the running buffer, but use the freshly prepared running buffer before using this process, and use the DD water instead of the distilled water only. And tips 2, so before using the running buffer you need to check visually whether any suspended particles present in this running buffer. So the running buffer is the pH is 7 around, so there is a higher chance of the contamination or bacterial growth. So that's what you need to check visually just before using this running buffer. And in some cases when you transfer this protein in the cell in the membrane, then you might find that in some cases this is not straight. So in some cases this kind of is tilted, as I included here in the image. So also in this case this is another cause of the when any kind of suspended particles present in the running buffer, and because of that the electricity is not equally flow. So this is why you need to use the freshly prepared running buffer and without having any suspended particles. And another problem is that when you transfer it in the in the membrane, then you might find that this kind of black line. So this black line is because of the stacking buffer. So when the stacking buffer is very old, in that case this kind of issue we find. So better you need to prepare the fresh stacking buffer for preparing the gel. So next is the transfer issues. So here is how you get that your protein is properly transferred in your membrane. So here is the tips that when you get the strong signal in your marker protein ladder, so if it is very strong, that indicating that your protein, all of the proteins are properly transferred in the membrane. So in this case transfer is okay, but if you find that this protein marker are very faint and these are not very strong, so in this case that indicating that the proteins are not properly transferred in the cell membrane, in the membrane. So this in this case that indicating that transfer problem. So here you need to first look at that how this kind of stack it arrange. So this is the check. First is the check the transfer was performed in the right direction. So here is the arrangement of the stack, that how this kind of is arrangement prepared. So gel, membrane, sandwich, and then the filter pads, and then sponge, and the electricity it flows from the black to the red, so from the negative to the positive side. So here as you see in this figure that the gel to membrane, so from the negative electricity from the negative to the positive, so electric flow from the gel to the membrane. So next is the activation of the PVDF membrane. So this is another point that is very important, this is if you use the PVDF membrane, then activation is obviously required, because this kind of PVDF membrane, these are highly hydrophobic, and this aqueous buffer it cannot penetrate properly. So this is why you need to activate this PVDF membrane in the methanol or transfer buffer containing methanol at least 10 minutes. So this is the pre-soaking of the PVDF membrane for 10 minutes. And after the protein, after the transfer, you need to use the OAS buffer, that is the TBST or TNET, and you need to use the 20% to in 20, that you make sure. So next is the transfer of proteins to the membrane can be checked using the Ponesius staining before the blocking step. So here is the staining. This staining, this Ponesius staining is reversible, and you can easily use it. Just couple of minutes you need to expose, and then just discard it, and then just once you wash with the water, then you can find that this kind of all of the proteins that it bind with this stain, so that indicating that your transfer is proper. And after that, I need to, when you detected that your transfer is proper, then you need to just remove it by water, the washing with the water, just 5 minutes, and it does not influence the antigen antibody binding. So next is the background noise. So this is the most common issues that we get in the Western blot. So here, as you see in this figure, in this that in this membrane there is a lot of background noise. So first is the improper washing. So in this case, the wash the membrane thrice and 10 minutes each wash with the TBST. So this washing step is very important. So you need to wash very properly with shaking. And tips 2, use NC membrane instead of PVDF, because PVDF has the higher binding affinity of the protein. So this is why you get the higher background. So in this case you can use NC membrane instead of the PVDF. Tips 3, so primary antibody incubation might too long. So in some cases people incubate more than 12 hours. So you need to make sure that that is not too long. And also the reduce the concentration of the primary antibody. So primary antibody, if you use 1:1000, then in that case you can try 1:2000. So it might overcome this kind of issue. Tips 4, the secondary antibody incubation should be 1 hour at room temperature. It should not be more than 1 hour. And increase washing period in case of the longer incubation. So if you incubate it more than 1 hour mistakenly, so you need to wash it properly, more than at proper washing, to remove this kind of background noise. And also the reduce the concentration of the secondary antibody. In this some cases you can try 1:10,000, that is recommended. And another common problem is the improper blocking. So that is another reason for the noisy background. So improper blocking. So here the tips is the 1 hour blocking, that is standard in 5% milk or BSA at room temperature using the orbital shaker around 25 rpm, or overnight at 4 degrees centigrade with shaking. But here you can see that this kind of black spot. So this black spot is because of the milk. So milk contain the casein, and this casein, it takes time to fully dissolve. So these are when the milk are undissolved, if this is not completely dissolved, then this might cause of this kind of black spot. So this is why you need to vortex for 1 minute this milk in the wash buffer and shake it for at least 1 hour to completely dissolve the milk. So this is the proper way using the blocking buffer. So next, another issue is the white spot. You might notice that in some cases in between band or in somewhere in the membrane, you'll get this kind of white spot. So this is because of the bubbles. So these bubbles trap inside in the membrane and the gel, and because of that, these bubbles, this white spot occur. So in this situation, you need to gently press the membrane manually to remove the bands when you before transfer, when you prepare the stack. So here you need to gently press manually to remove this kind of bubbles. So next is the faint band issue. So here, so in some cases your marker are very strong, but you will get the band, those are very faint. So here is the another the problem, that is you need to follow these tips. Increase primary antibody concentration, 1:1000 recommended. So if you use 1:2000 or 1:3000, so you can increase the concentration to 1:1000. Increase the incubation time overnight at 4 degrees centigrade with shaking, and use the secondary antibody around 1:10,000. So tips 2, protein of interest is not present in some cases, and run a positive control. So if you run a positive control and if you compare with the positive control, then you might understand that what is the problem. Tips 3, if you use IR dye conjugated secondary antibody, then you can try HRP conjugated secondary antibody, because HRP conjugated secondary antibody, it has the higher sensitivity. So tips 4 is the sodium azide is an inhibitor that we usually use in the and the buffer that we use normally for the antibody dilution. So for the secondary antibody dilution, you should not use the sodium azide if you use the HRP conjugated antibody, because sodium azide is an inhibitor of the HRP and it is unsuitable for use with the HRP conjugated antibodies. So also you can find that in some cases your bands are not equal, so the shape of the bands are different, so that indicating the insufficient binding of the antibody. So in this case you need to increase the primary antibody concentration to 1:1000, and also you need to increase the incubation time overnight at 4 degrees centigrade with shaking. So in this case you will get the proper binding and you will get the equal shape of the band. So next is the if you detect the phospho-specific antibodies, and this kind of phospho-specific antibodies, it may react with the milk blocking agent due to the presence of the phosphoprotein casein. So casein actually is a phosphoprotein. So so for example, like if you want to detect the P protein X, this protein that is a phosphoprotein, so for that you need to use the primary antibody anti phosphoprotein X, this antibody, to detect this protein, right? But milk contain casein. So casein actually this is the kind of the phosphoprotein. So this, if you use the milk here, so this primary antibody anti P protein X, it can bind with the casein and you will get the some background noise in this case. So this is why if you want to detect the phosphospecific protein, then you should not use the milk for the as a blocking agent. So in this case you need to use the 5% BSA to block your membrane. So next is the antibody dilution buffer. So usually the 1% 5% BSA in sterile TNET TBST to dilute the antibody. So for primary antibody, if you want to preserve it for longer time, so in that case you need to sterile the TNET or TBST buffer that you wanna dilute your antibody, and you also need to add the sodium azide in this primary antibody buffer. So this is the proper dilution buffer you need to follow. So I hope this video will be helpful. So if you like this video, kindly hit the like button, and if you have any more issues that I did not cover here in this video, you might write in the comment section that what kind of specifics. So I hope this video will be helpful. If you like this video, kindly hit the like button, share it, and please subscribe my channel. Thanks for watching.